Welcome to qnawire.
Over here we're going to mix equal volumes of 45 millimolar HCl with 90 millimolar tris-free amine. So let's put this as an amine. In this case, tris is going to represent tris-hydroxymethyl aminomethane, but at the end of the day, the only important thing is that the structure contains an amine group that is going to be basic. So when we combine these quantities, what is going to occur is that if we write down our ice table, since the volumes that we added are the same, then the amount of mole that we added are going to be related. So the amount of mole of HCl is going to be equal to 1/2 the amount of mole of the amine. So initially, for this reaction, we're going to get that the amine is going to react with HCl to produce the protonated version of the amine plus water. Plus Cl minus in this case. So the initial amount of amine, let's call it N0. The amount of HCl is going to be 1/2 of N0. We're going to be beginning with 0 and 0. The amount of change is given by the limiting reagent, which is the HCl. So minus 1/2 of N0, minus 1/2 of N0, 1/2 of N0 as a positive, and plus 1/2 of N0 as a positive. So at equilibrium, we're going to get 1/2 of N0, 0, 1/2 of N0, and 1/2 of N0. So now, what we notice is that we're going to have at the same time a weak acid, that is the ammonium ion associated to this amine group, and we're going to have its conjugate base. And both of them are going to be in the same quantities. It doesn't matter the volume, the amount of mole is going to be the same, thus the concentrations are going to be the same. So we're told that the pKa is going to be equal to 8.3 times 10 to the minus 2, which makes no sense. I think that this is going to be a typo. Actually, looking at what is the value for the pKa of trees, it is actually closer to 8.07. So probably the pKa that should appear in this case should be 8.3. So you can check that up on your question, but what we're going to have is that the solution is going to be a buffer and the pH is going to be equal to the pKa, because according to the Henderson-Hasselbalch equation, the value for the pH is going to be depending on the ratio of the concentrations. In this case, the ratio is equal to 1, because we have the same quantities of each of them, and the logarithm of 1 is 0. So the pH should be equal to the pKa of the compound that is given to you. So with that, it would be all. Thank you very much, and have a good one.